Hi. Today's lesson is on graphing systems of inequalities. So a system of inequalities is just two inequalities. That's all it is. And to solve a system of inequalities by graphing, all you do is graph of both inequalities. Don't forget the shading. And then wherever the shading for each inequality overlaps, any points in the double shaded area, those would be solutions to that system of inequalities. So go ahead though and pause the video and read through examples 1 and 2. Great. Let's do some problems together. All right, so you have 6 problems and it just says solve each system of inequalities by graphing. So I'm just going to skip around and do some of the ones that might be a little bit more challenging first. So let's just skip to number 4. So my inequalities are 2x plus y is greater than or equal to 1 and x minus y is greater than or equal to negative 2. So just like I was doing before, I'm going to pick 2 different colors to graph the lines with. And then I'm also going to do my shading, but I'm going to use the highlighter tool for the shading part. So the first inequality is 2x plus y is greater than or equal to 1. So let's rewrite this inequality. Let's rewrite this inequality in slope-intercept form. So it's going to be y is greater than or equal to 1 minus 2x. The inequality symbol isn't going to flip here. And then if I flip-flop the negative 2x and the 1, it becomes y is greater than or equal to negative 2x plus 1. And so I'm going to graph this. I'm going to start off graphing this the same way that I would graph an equation. So my slope is negative 2 over 1, and my y-intercept is 1. So start off the same way. I find 1 on the y-axis. If my slope is negative 2 over 1, that means I'm going to go down 2 and then right 1. And make another point. Down 2, right 1, down 2, right 1. Or I can go up 2, left 1. Okay, now before I draw my line, I need to determine should it be a solid line or should it be a dashed line. Well, my inequality symbol is the greater than or equal to. So if you have that or equal to part, then you're going to make the solid line. So I'm going to make my solid line. Okay, and now I have to do my shading. So do I shade above the line over here, or do I shade below the line over here? Well, you can pick a test point, a point that's not on the line, and see if that point is a solution. So for example, 0, 0 is not on the line, so I could see if 0, 0 would be a solution by plugging 0 in for x and y here and solving. But you probably have already guessed from a previous lesson when we're graphing an inequality, if the inequality is written in slope-intercept form, which this one is, that greater than or equal to means I'm going to be shading above the line. So in this case, I already know that I'm going to be shading above the line. So let me get my, I'm trying to get a pink color highlighter. Okay, so that means I'm going to be shading this side. Because 0, 0 will not be a solution to my inequality. Okay, so I've graphed the first inequality. Now I'm going to graph the second inequality. So the second one is x minus y is greater than or equal to negative 2. So again, I'm going to put this in slope-intercept form. So I end up with negative y is greater than or equal to negative 2 minus x. Now that's a negative y, so I need to divide everything through by negative 1 or multiply everything through by negative 1. Same thing. When I multiply or divide both sides of an inequality by a negative number, my inequality symbol flips. So instead of the greater than or equal to symbol, it's going to flip around, so it'll be less than or equal to. And then multiplying everything else by negative 1, so that'd be 2 plus x. So that's going to be y less than or equal to x plus 2. So my slope here is 1 over 1. And my y-intercept here is 2. So I find 2 on the y-axis. And then my slope, use my slope to generate more points. So that's up 1, right 1. Or down 1, left 1. Okay, now before I draw in my line, again, I need to determine, is it a solid line or is it a dashed line? Well, it's the less than or equal to, so it's got that or equal to part, so it's going to be that solid line. So I'll make my solid line. If it was just plain old less than, then it would be dashed. All right, now I've got to figure out my highlighting. So when I do my highlighting, again, am I shading above the line or am I shading below? Well, the inequality, look at the part where it's written in slope-intercept form. So it's the less than or equal to, so that's going to be below the line. But you could also pick that test point, and a 0, 0 is not on that green line. So if I put a 0, 0 in for x and y there, it'd be 0 is less than or equal to 0 plus 2. Yes, 0 is less, so 0, 0, 0 is a solution. All right, so now I'm going to do my highlighting. And I'm going to go this way. Okay, so there is actually, let me undo. There we go, because I wanted you to be able to see that y. Okay, so the solution to this system of inequalities is going to be the part where both the pink and the green shading overlaps. So that's going to be right in through here. All of this area right here, just so you know. So any point that falls in this section would be a solution to that system of inequalities. Okay, so that's basically all there is to it. So I'm going to have you go ahead now, and I do want you to do the rest of these problems. So graph both inequalities, and then do your shading. Pick 2 different colors so that way you can see where the shading overlaps and you can see where exactly the system is. All right, good luck. Hey guys, welcome back. So I've graphed each of these systems of inequalities. Remember that the solution to a system of inequalities is where the 2 shaded areas overlap. So I'm going to zoom in on some of these. I colored over in orange the part where the blue and the purple overlapped. I did that for each problem. Remember that if you have a dashed line, those points are not solutions to that particular inequality. Okay, so those are just the boundaries. So here's number 1. And let's see, there's number 2. Number 3. We did number 4 together already, so there's number 5 and 6. Oops, sorry about that. 5 and 6. Okay, so if you have questions about any of these problems, or if there's anything you're stuck on and don't understand, bring it to my attention so that I can assist you. Go ahead and turn this in once you've made the necessary corrections, and then start on your independent practice. Good luck!